let's move on to the question number 23. Vapor pressure of a solution of a non-volatile electrolyte A in a solvent B is 95% of the vapor pressure of the solvent at the same temperature. So, that means vapor pressure of a solution Ps is equal to 0.95 of P naught is the vapor pressure of the solvent. Ps is the vapor pressure of the solution. The vapor pressure of a solution of a non-volatile electrolyte Ps is in a solvent is 95% of the vapor pressure of the pure solvent at the same temperature. Now, if Mb is equal to 0.6 Ma, so this is vapor pressure of solution, that is A plus B, is equal to 0.95 of Pa, right. Non-electrolyte A is equal to solvent B, right. Then Mb is equal to, given is that 0.6 Ma, where Mb and Ma are molecular weights of B and A respectively. The weight ratio of the solvent and solute are the weight ratio of solvent and solute. For this, what we can write is that, applying the Raoult's law, P naught minus Ps by P naught is equal to mole fraction of solute. This is what we are supposed to use. So, this is P naught minus Ps. P naught minus Ps is equal to, so this is equal to 0.95 of Pb, right. Therefore, P naught minus Ps is nothing but P naught minus 0.95 P naught by P naught, that is equal to what? 0.1 minus 0.05. 0.05 is equal to mole fraction of solute. Mole fraction of solute is nothing but weight of solute by molecular weight of solute. Molecular weight of solute is 0.6 molecular weight of A by weight of this 0.6 Ma plus weight of solvent by Ma, right. Now, the question asked is that what is the relation between Wb and Wa. So, the weight ratio of solvent and solute. So, the question is that Wb by Wa. So, this is Wa by Ma. Wa by Ma is equal to Wa by Ma plus Wb by 0.6 Ma. From this 0.05 is equal to mole fraction of solute. Solute is what? Solute is A. So, that is Wa by Ma. Mole fraction of solute is nothing but number of moles of solute by number of moles of solute plus number of moles of solvent. So, number of moles of solute is Wa by Ma divided by Wa by Ma, that is number of moles of solute, and this is Wb by 0.6 Ma. So, this if you solve, then what we will get is the ratio of the solvent and solute. Solvent is Wb, solute is Wa, ratio of these two, finally we get it as 5.7. So, the answer must be option B. Now, let us move on to question number 24. In the question, what it says is solute A is a ternary electrolyte. Ternary means 3 ions that it produces, like in the formula Ab2 type, which dissociates to like A2 plus plus 2B minus. So, for this, if it undergoes 100% dissociation, if alpha is equal to 1, we consider a strong electrolyte, then for this I factor will be equal to 3. And solute B is a non-electrolyte. This is solute A. Solute B is non-electrolyte. Non-electrolyte means it is something like X. So, for this I is equal to 1. If 0.1 molar solution of solute B produces an osmotic pressure of 2P. So, the question is osmotic pressure, pi equal to I into C into R into T. Now, pi A is equal to, that means Ab2 type, I is 3 into C into R into T, and pi B is equal to, that is for solution B, then it is I is equal to 1, so it is only C into R into T. Now, in the case of the question, in the question what more it is given, then 0.05 molar solution of A, solute B, 0.1 molar solution of solute B, means this C is equal to 0.1 RT, that produces an osmotic pressure of 2P, then 2P is equal to 0.1 RT, then 0.05 molar solution of solute A, means this pi A will be what if it is 3 into 0.05 RT. So, means 0.1 RT is equal to 2P, this is equal to 0.15 RT. So, pi B is equal to 2P, which is 0.1 RT. So, 0.15 RT will be what? This will be equal to 3P. So, the answer must be 3P, that is option D. Now, let us go to question number 25. In this question, the given information is that at 40 degrees Celsius, the vapor pressure in torr of methyl alcohol ethyl alcohol solution is represented by the equation that vapor pressure of the solution is equal to 119 XA plus 135. This is what is the information that is given, where XA is the mole fraction of methyl alcohol. XA is the mole fraction of methyl alcohol. Then the value of limit XA tending to 1 PA by XA. Limit XA tending to 1, when XA is tending to 1, then obviously, then if XA tending to 1, then PS is equal to 119 plus 135, that is equal to 254, that is equal to 254. Where XA is mole fraction of methyl alcohol, then the value of limit XA tending to 1 PA by XA. Then what is PA? That PA by XA is that PA is nothing but when XA is tending to 1, then this is equal to 254. Then this is nothing but then PA, because XA is equal to 1 means what? Mole fraction of A is 1, mole fraction of B is 0. That means it is only pure liquid A. So, then mole fraction will be 1. So, then it is equal to 254 by 1, that is equal to 254 torr. Right? If XB is equal to, if XB tending to 0, if XB tending to 1, if XB tending to 1, of course, this is not asked in the question, but this type of question can also be asked, that if XB tending to 1, then if XB tending to 1, then XA will be 0. Then in that case, it will be 135. So, here what we have to understand is that partial vapor pressure of A is 254 torr, I mean PA naught will be 254 and PB naught is 135. This is what the information we can get. So, PA naught is 254, XA tending to 1 is nothing but PA naught. So, this is equal to 254. So, the answer must be option A. Now, let us move on to the question number 26. Y grams of a non-volatile organic substance of molecular mass m. Weight is equal to y grams, molecular weight is equal to m. So, number of moles is equal to, number of moles of solute is equal to y by m. Then molar elevation constant of benzene is Kb. So, Kb is Kb, right. Then elevation in its boiling point is given by delta Tb is equal to Kb into molality. So, delta Tb is equal to Kb into molality, where Kb is the molar elevation constant of benzene and m is of course the molality. Molality is nothing but weight of solute by gram molecular weight of solute into 1000 by molecule 1000 by weight of the solvent. What is the weight of the solvent given? 250, right. So, this is equal to y by 4m. So, delta Tb is equal to Kb into y by 4m, right. So, it is delta Tb is equal to Kb into y by 4m. So, the answer must be option C. Now, let us move on to the question number 27. that in the question it is given that the amount of ice that will separate out and cooling solution containing 50 grams of ethylene glycol in 200 grams of water to minus 9.3 degrees Celsius is. Now, here what we have to do is, initially given weight of water is 200 grams. Now, when 50 grams of ethylene glycol is added, if it freezing point is decreased to 9.3 minus 9.3, then what is the molality of the solution, or what is the weight of the solvent, then that we have to find out. So, basically the thing is, initial weight of solvent, that is water, is 200 grams. Now, on adding 50 grams of ethylene glycol, delta TF is minus 9.3. Now, delta TF is equal to Kf into molality, that is 9.3 is equal to 1.86 into molality. So, from this molality is equal to 9.3 by 1.86, that is equal to 5. So, it is 5 molal. So, that means molality is equal to 5 is equal to weight of ethylene glycol. Weight of ethylene glycol given is 50, then its molecular weight is 58 into 1000 by weight of solvent, that is water. That if you do it, you will get this as weight of water, almost you get it as about some 172, 172.3 approx we get. So, that means difference. So, then that means weight of ice that is separated out is equal to initial weight of the water, that is 200 minus 172. So, the weight of ice separated out is equal to initial weight of water minus the weight of water that is obtained after adding that what you call the ethylene glycol to whatever the temperature that it is raised. So, from this what we get, that is 172.3. So, this if you do, it approximately comes out to be 28 grams is nearly the weight of ice that separates out. So, the nearest answer here is the option A, that is 28.71 grams. So, the correct answer is option A. Now, let us move on to question number 28. The Van Hoff factor for 0.1 molar barium nitrate solution, I equal to, Van Hoff factor equal to 2.74. Van Hoff factor for 0.1 molar barium nitrate solution is 2.74. The degree of dissociation is, as now it is barium nitrate, for barium nitrate N is equal to 3, that is total number of moles, because barium nitrate is a ternary electrolyte, dissociate into Ba2 plus 2NO3 minus. So, if alpha is equal to 1, then N is equal to 3. Now, so from this alpha and I relation, if you write for dissociation, the relation for alpha and I is that alpha equal to I minus 1 by N minus 1, that is 2.74 minus 1 by 3 minus 1, that is 1.74 by 2. 1.74 by 2 is nothing but 0.87. So, that is percentage alpha is equal to 87%. So, the answer must be option B. Now, let us go to the question number 29. The elevation in boiling point of a solution of 13.44 grams of CuCl2, whose molecular weight is 134.4 in 1 kg of water is, Kb for water is given as 0.52 Kelvin kg per mole, right, and here the weight of CuCl2, given is 13.44 grams, and the molecular weight of CuCl2, gram molecular weight of CuCl2 is 134.4. So, from this number of moles of CuCl2 is equal to 0.1, and weight of solvent is 1 kg. So, molality is equal to 0.1 molal. Now, the question is, what is the elevation in boiling point? So, delta TB is equal to Kb into molality, that if we take, then this is equal to 0.52 into 0.1, that is equal to 0.052 is the answer. Now, this is if the assuming CuCl2 will not undergo any dissociation, but CuCl2 being a ternary electrolyte, the N is equal to 3 or sorry I is equal to 3 for CuCl2. So, therefore, delta Tb is now equal to I into Kb into molality, that is equal to 3 into 0.052, that is equal to 0.156, that is approximately 0.16. So, the answer must be option A. Now, let us move on to the question number 30. Which of the complex in its 1 molar solution with 100% ionization will show a boiling point of 102.05 degrees? Kb for water is 0.52 Kelvin kg per mole. Now, the question is that 100% dissociation means alpha is equal to 1. When alpha is equal to 1, well, of course, the 1 molar ionization will show boiling point of 102. So, delta Tb is equal to Kb into molality, and this delta Tb obviously is equal to what? 2.05 degrees. So, 2.05 must be equal to Kb into I into molality, that is 2.05 is equal to 0.52 into I into the molality is what? 1 molar solution, 1 molar solution. So, this is 1. So, from this I must be equal to what? 2.05 by 0.52. So, this must be equal to about I equal to 4. So, that means alpha is equal to 1 and I is equal to 4. Alpha is equal to 1 and I is equal to 4, implies N is equal to 4, means total number of ions what we should get should be equal to 4. So, the answer must be K3FeCN6. K3FeCN6 will give you 3K plus 1 complex ion FeCN6 minus, FeCN6 3 minus. So, this is 3 plus 1, that is 4 ions, whereas if you take any other, first option A if you take, you will get 4 ferric ions and 3 ferrocyanide ions. So, it will be total 7. Option B it is 4, option C it is 4 plus 1 5, option D it is 1 plus 1 2. So, our answer should be 4. So, that means the option correct option must be option B, K3FeCN6, where we will get N equal to 4. Now, let us move on to the question number 31. The elevation and boiling point of a solution delta Tb is related to delta Tb or dTb, anything we can write, related to molality by the relation that delta Tb is dTb or otherwise it is equal to RTb square, that is nothing RTb square by delta H vaporization into M1 by 1 plus MM1, where M1 is the molar mass of the solvent, delta H vaporization is heat of vaporization of solvent. Then for a dilute solution, the relation delta Tb by delta M, where M tending to 0. When M tending to 0, right, then this will become M1, then this is equal to R. If M tending to 0, then this delta Tb will be equal to RTb square by delta H vaporization into M1, that is molecular weight of the solvent. So, this is in fact is nothing but Kb, because what? Kb is equal to RTb square by 1000 LV, or which is equal to RTb square by instead of you will write it as M1 by delta HV, right. So, this is into M1, this M tending to 0. So, this whole thing will become 1 when this denominator, this is 0, then this denominator is 1, when this denominator is 1, then delta P is equal to RTB square into M1 by delta H vaporization, and this is nothing but Kb RTB square by m delta H vaporization. So, this is equal to Kb. So, this is nothing but molal ebuloscopic constant Kb. So, the answer must be option A. In the question number 32, in this question it is given if quantities delta Tf, delta Tb, delta P and pi without subscript refer to electrolyte solution, means there we are supposed to take I, right. That means whether the pi equal to ICRT or delta Tb equal to I into Kb into molality, this is for electrolyte solution, and similarly P naught minus Ps by P naught is equal to I into mole fraction. Okay. Like this if we take, and this is subscript without subscript. So, these are the with subscript means P naught and all. So, P naught naught, Tf naught etc. Pi naught then will be equal to CRT, and like this when you write, then here if pi naught equal to CRT, then pi equal to I into pi naught. So, I equal to pi by pi naught, right. So, I equal to pi by pi naught. Similarly, delta Tb is equal to I into Kb into molality, and delta Tb naught is equal to Kb into molality. So, like this if you keep writing, then what all you will get is that now this delta here I is equal to delta Tb naught by delta Tb, delta Tb naught by delta Tb, and similarly even delta Tf by delta Tf naught, here I is equal to delta Tb naught by delta Tb, right. And similarly also similar way if you write I equal to delta Tf naught by delta Tf. And then if you come to this, now coming to the vapor pressure case, P naught minus Ps by P naught is equal to I into x is even that what we are writing without subscript. Then with subscript if it is P naught minus Ps by P naught naught will be equal to mole fraction x. So, that if you substitute you will get I as that P naught naught by P naught. So, now if you look at all the 4 options, I equal to pi by pi naught is the correct expression for I, the remaining 3 are wrong. So, the correct answer must be option D. Now, let us go to question number 33. Benzene and toluene form nearly ideal solutions. At 20 degrees Celsius, the vapor pressure of pure benzene is 75 torr and that of toluene is 150 torr. Then vapor pressure of a solution containing 78 grams of benzene and 46 grams of toluene. So, here it is a mixture of 2 liquids for which the total vapor pressure of the solution is equal to XA PA naught plus XB PB naught, where PA naught and PB naught are the vapor pressures of the pure solvents, say benzene and toluene. XA and XB are mole fractions of the 2 liquids. Now, here X benzene is equal to N benzene by N toluene plus N benzene. N benzene is 78 grams. So, here N benzene is equal to 78 by 78, that is equal to 1, and N toluene is equal to 46 by toluene molecular weight 92, it is 0.5. So, this is 1 by 1.5 and X toluene is equal to 0.5 by 1.5. Now, that if you do it, now the given is that the mixture, what is the vapor pressure of the mixture? So, it is vapor pressure of the solution is equal to now 78 by 1.5 plus, that is 78 1 by 1.5 plus 0.5 by 1.5 into what you call this toluene. Here PB naught benzene is equal to, the given is 75 torr. So, this is 75 and P naught for toluene is 150. So, into 150. this if you do, this is equal to 75 plus 0.5 into 150 by 1.5. So, this is 0.5 into 150, that is 75. 75 plus 75, 150. 150 by 1.5, that is 100. So, vapor pressure of the solution must be equal to 100. So, the correct answer must be option D. Now, let us move on to the question number 34. The azeotropic mixture of water with boiling point 100 degrees Celsius and HCl boiling point 85 degrees Celsius boils at 108.5 degrees Celsius. So, it is maximum boiling azeotrope. The boiling point of the azeotrope is greater than the boiling point of both the liquids. Now, whatever it is, but when the mixture is distilled, is it possible to obtain pure HCl? No. Pure water? No. Pure water as well as HCl? Absolutely no. Neither HCl nor H2O? Yes. Neither we can get pure HCl nor we can get pure H2O, because that is what the azeotropic means. Whenever you take an azeotropic composition, then neither you get pure HCl nor you get pure water. It is not possible to separate the either of the liquids into pure components. Therefore, the correct option must be option D. The question number 35. Now, in the question number 35, it is given is osmotic pressure of a 5% weight by volume solution of cane sugar. First of all, cane sugar is C12H22O11. Its molecular weight is 342. Then molarity of 5% weight by volume solution is 10 into 5 by 342, because molarity is equal to 10x by gram molecular weight, where x percent weight by volume solution is given. So, this is molarity. Now, pi equal to C into R into T. C is molar concentration, that is 10 into 5 by 342 into R, gas constant 0.081 liter atmosphere, and temperature given is 150 degrees Celsius. 150 degrees Celsius means 273 plus 150 Kelvin, that is 312.4. So, it is 423. Now, this if you solve, you will get this as 5.078 atmosphere. So, the osmotic pressure of a 5% solution of cane sugar at 150 degrees Celsius is 5.078 atmosphere. So, the correct answer is option C. Now, let us move on to the question number 36. The average osmotic pressure of human blood is 7.8 bar at 37 degrees centigrade. What is the concentration of an aqueous NaCl solution that could be used in the blood stream? So, it is the average osmotic pressure pi, that is given as 7.8 bar at 37 degrees Celsius. So, in order to have the equal osmotic pressure, basically the point is that when you take pi equal to CRT, this pi you have to take it as 7.8 bar, that must be equal to concentration of NaCl, that should be the number of moles. Then it is what is the concentration of an aqueous solution, that means C is the one that we have to find out, that C into R 0.0821 into temperature that is given is 37 degrees Celsius, means it is about 310. Now, this if you calculate, what you will get is, so from this what you will get is that 7.8 by 0.0821 into 310, and this being NaCl, I factor must be equal to 2, that also if you take into consideration. So, this is into 2, right. So, this is equal to 2 into 0.082, 7.8 by 2 into 0.081 by 310, that if you do, you will get this as 0.31 mole per liter. So, the correct answer must be option B. Let us move to question number 37. Which of the following aqueous solutions produce the same osmotic pressure? 0.1 molar NaCl. NaCl is a strong electrolyte, so I factor will be 2. So, actual concentration 0.1 molar NaCl for this particle concentration is equivalent to 0.2. 0.1 molar glucose, 0.1 molar glucose. So, that glucose is a non-electrolyte, so it will remain 0.1. 0.6 grams of urea, urea molecular weight is 60. So, 0.6 is 0.01 and 1 gram of non-electrolyte solute X in 50 ml solution whose molecular weight is 200. So, for that we have to find 1, 2, 3 and the fourth option is that 1 gram of a non-electrolyte in 50 ml. So, 1 by 200 into 1000 by 50. So, this is 20, this is 10, this is 0.1. So, this is equal to 0.1. So, these are the particle concentrations and it is a, now which of the following aqueous solutions produce the same osmotic pressure? So, this one and the fourth, as both of them are 0.1. So, the it should be, it's 0.6 grams of urea in 100 ml, this is also 0.1 because urea molecular weight is 60. So, 0.6 by 60 into 1000 by 100, that is also 0.1. So, this is also 0.1. So, it is 2, 3, 4, all 2, 3, 4 will give same osmotic pressure. As pi is equal to I into C into R into T, all these 3 are non-electrolytes, concentration is 0.1, I is equal to 1. So, it should be second, third, fourth, that is the option B. Now, let us move on to the question number 38. If for a sucrose solution elevation in boiling point is 0.1 degree Celsius, then what will be the boiling point of NaCl solution for the same molar concentration? Sucrose solution is a non-electrolyte. So, for sucrose solution I is equal to 1 and for NaCl solution I equal to 2. So, when this what you call the elevation in boiling point, when you write delta Tb is equal to I into Kb into molality, if for same molar solution of both if you take, then I as it doubles to the NaCl. So, for sucrose if delta Tb is equal to 0.1, then for NaCl this delta Tb will be equal to 0.2 for same molality. So, the answer must be option B. Now, let us go to question number 39. In the question given, the molar freezing point constant for water is 1.86 degree Celsius per mole or 1.86 Kelvin kg per mole. If 342 grams of cane sugar are dissolved in 1000 grams of water, then the solution will freeze at 342 grams of cane sugar, 342 grams of C12H22O11. This is equal to 1 mole. Now, this in 1 liter, this is 1 molar. Delta Tf is equal to Kf into molality. So, this is in 1000 grams of, in 1000 grams or 1 kg, then this is 1 molar, either way it is the same. So, now delta Tf is 1.86. So, 1.86 into or molality, that is 1, is equal to delta Tf. So, the answer must be minus 1.86 because now it is the freezing point. So, decreases by 1.86. So, Tf is minus 1.86 degree Celsius, minus 1.86 degree Celsius. So, the correct answer is option A. Now, let us move on to the question number 40. The freezing point of 1 molar NaCl solution, assuming NaCl to be 100% dissociated in water, is molar depression constant, again Kf for water is 1.86 Kelvin kg per mole, and molality of NaCl is given as 1 molar. I factor for NaCl is equal to 2 if alpha is equal to 1 because it is given that 100% dissociated. So, delta Tf is equal to Kf into molality, that is 1.86 into 2. So, this is equal to 2.72. So, this is delta Tf is equal to Kf into molality, this is 1.86 into 2, this is equal to 3.72. So TF is equal to minus 3.72 degrees Celsius. So the correct answer must be option B. Now let's move on to the question number 41. After adding a solute, freezing point of solution decreases to minus 0.186. Calculate delta TB if Kf is equal to 1.86 and Kb is equal to 0.2521. Right. After adding a solute, freezing point of solution decreases to minus 0.186. Calculate delta TB. Right. Now, Kf is equal to 1.86 and freezing, after adding a solute, freezing point of solution decreases to minus 0.186. So delta TF is equal to minus 0.186. Then or rather delta TF is equal to 0.186. Then the Kb is 0.521. So the question is calculate delta TB. So from this, delta TF is equal to Kf into molality. So first what we have to do is we have to find out molality. So delta TF 0.186 is equal to 1.86 into molality. So molality is equal to 0.186 by 1.86, that is 0.1. Right. Now using this molality, now find out delta TB. Now delta TB is equal to Kb into molality, right? Kb is 0.521. So this into 0.1, this is 0.0521. So delta TB must be equal to 0.0521. So the answer must be option C. Now let's move on to the question number 42. When 10 grams of a non-volatile solute is dissolved in 100 grams of benzene, the boiling point is raised by 1 degree Celsius. Then what is the molecular mass of the solute? So delta TB is equal to Kb into molality and it is a non-electrolyte, so I is equal to 1. Now delta TB is that it raises the boiling point by 1 degree Celsius. So delta TB is equal to 1 and Kb for benzene is given as 2.53 into molality. So molality is equal to 1 by 2.53, which is equal to weight of solute, that is 10 grams, by molecular weight of solute into 1000 by weight of solvent. Weight of solvent, that is benzene weight, that is given is 100. So this is the molality. So from this, if you determine then molecular weight, you will get it as 253 grams. So the correct answer must be option D. Now let's go to question number 43. If 0.15 grams of solute is dissolved in 15 grams of solvent, then it is boiled at a temperature higher by 0.216 degrees Celsius than that of pure solvent. The molecular weight of the substance is, so here the question is that, so the increase in boiling point is 0.216. So delta TB, once again it is delta TB is equal to Kb into molality, and that if you take, now delta TB is 0.216 is equal to Kb, molal elevation constant for the solvent is 2.16 into molality. So from this, molality is equal to 0.216 by 2.16, that is equal to 0.1. So it is 0.1 molal, and so this is equal to weight of solute, that is 0.15 gram by molecular weight into 1000 by weight of solvent is given as 15 grams, right. So this is, now if you do this is 100 and so this is 10. So now it is that 0.1 is equal to 10 by m, m is equal to 10 by 0.1, that is 100. So molecular weight of the solvent is 100. So the answer is, the correct option is option A. Now let's go to the question number 44. In the question number 44, it is given the molar elevation constant of water is 0.52 degrees Celsius, 0.52. The boiling point of 1 molar aqueous solution of KCl is, molality of KCl is 1 molar and I factor for KCl is equal to 2 because alpha is equal to 1, and so delta TB is equal to I into Kb into molality, that is 2 into 0.52 into 1, that is 1.14. Therefore, TB is equal to 100 plus 1.14, that is 101.14 degrees Celsius. That is option C is the correct answer. So, with this we have discussed in length about the concepts of liquid solutions, colligative properties, their applications, conceptual questions based on applications as well as the concepts, numerical problems, different types with respect to all colligative properties, ideal and non-ideal solutions, azeotropic mixtures. Regarding all this, we have done extensively the theory part and also did numericals. So, with this we can conclude the chapter of this liquid solutions. Thank you very much. All the best.